Hi, welcome to Python Lab. Today I'm going to show you how to calculate probabilities using binomial distributions and how to plot the probabilities of binomial distributions using matplotlib. So binomial distribution is one of the most popular distribution in statistics along with normal distribution. What is actually there are two types of distributions: normal distribution and binomial distributions. The main difference is that the normal distribution is continuous random values, whereas binomial distribution is a discrete distribution. But if there are enough data points, it will be quite similar to the normal distribution with certain log and scale. So generally, we will focus on binomial distributions because they are almost similar. But my intention is going to calculate the probabilities of binomial distributions using Python. So it is a discrete distribution. Discrete means the values of the variables are countable. That is called discrete distribution. It describes the outcome of binary scenarios because it is binomial. Binomial bi means two values. So the outcome of two binary scenarios. For example, choice of a coin, it will be either head or tails. It has two outcomes, either head or tails. That is the scenarios of binomial distribution. Binomial distribution is a discrete probability distribution of a number of success x in a sequence of independent experiments n. Each experiment has possible outcomes, success and failure outcomes. The success outcome has a probability of p, and failure has the probability of 1 minus p. So the two outcomes, the sum of the two outcomes equal 1. So if we get the probability of the success of the possible outcomes of success, then we can subtract that probability of success from the probability from 1, and we get the probability of failure. Okay, let's calculate probabilities using Python. How can we, for example, suppose we flip a fair coin 10 times, that is, we experiment this coin 10 times, or that is a 10 times trial experiment, and count the number of heads, how many number of heads we flip from 10 experiments. We can use the binom.pmf function or method from SciPy function to calculate the probability of observing 6 heads as for that. First, let's import the SciPy. Import SciPy.stats as st. So the SciPy provides algorithms for optimization, integration, interpolation, eigenvalue, problems, algebraic equations, different equations, and statistics, and many more algorithms or equations. So that SciPy is generally focused on mathematical equations and statistics. So this is a powerful library, Python library, to calculate the probabilities and statistics, especially to work on statistical analysis. So we have given the number of experiments or trials, that is n is 10, and the possible outcome, then calculate the probability of observing 6 heads. So the number of heads are 6, and the probability of success is 0.5. That then what is the probability of these 6 heads? We experiment 6 heads 10 times. So that is what is the probability? Let's calculate using this binom.pmf function. Then we pass the parameters as an argument, x and the number of size and p. Then let's print the probability of this to get the result. So that is the probability that the outcome of this counting the number of heads from 10 experiments from 10. When you flip the coin 10 times, so you get the 6 heads. That is the probability of 6 heads is from 10 experiments is at 0.2. So the other is either that is from 10 experiments, 4 is tile, right? So 8%, almost 20% is the probability of the number of heads from 10 experiments is almost 20%, and the other is tile. Okay, what is probability mass function, PMF? This is from this SciPy Python library. So what is this type? A type of probability distribution that defines the probability observing a particular value of a discrete random variable, that observing the probability of a particular value of a discrete random variable, because binomial distribution is a discrete random distribution. This method takes 3 values. X is the value of interest, that is the number of heads or the number of tiles that we want to count, and is the number of trials that the coin flips, how many number of experiments we want to flip the coin, how many number of times, that is the number of trials. And P is the probability of success in each trial. So the probability of failure is 1 minus probability of success. So from this example, so the probability of print 1 minus P, 1 minus probe. So almost 80% is failure. That is tile. It is a tile of this. So then plot the probability of flip a pair coin. Let's plot this to count the number of heads and find the probabilities of heads using matplotlib. And let's here let's define the library. First, let's define the library from matplotlib, import pyplot as PLT, and we also import to slide the number of heads trials, import ipy gets as this one. Okay, then let's define, let's get dot interact, let x slider, that is let's set the minimum of the slider 1 and maximum of the slider is 10, and a step that is increased by from one step to one another step that is by 1, and the maximum step value is 10. Then we define a function plots probability, and we pass that x to this. And for let's calculate the probability of and store in a list for every I in range of 0 to x, 0 to x. When you flip, then prob dot append that probability of from sct dot binom dot pmf. Then we pass I as the number of heads that we want to count, and x is the number of experiments. The number of experiments we want to trial, or the number of trials, and 0.5 is the probability of success. Then let's plot this probability dot figure fixed size. Let's say the fixed size, for example, 6 by 3, 6 where width and the height is 3. That is 600 by 300. And then we plot the bar plots, and we pass the range 0 to 11 as x value to the x side, and the probability to the y, and then we pass color, it's brown. And probability, let's define x level, the level of x. That is probability. I mean, x is number of heads, and probability does y level, that is probability. And we can set the grid for grid, and color, you can set the color R, red, and we can set x ticks, that is in the range of 0 to 11, between 0 to. Then finally we ability to show. Let's run this and let's see. Okay, we get here. I forget S. Okay, there is error. Shape mismatch in. There is zero 11. I mean, this is 11. Sorry, 0 to 11. This is I mean, PLC. Okay, here there is something error. PLC. Okay. Okay. Now we get this exact. This number of trials are 10, and number of heads we can count. The number of heads are 0 up to 10. That is 10. Then here's the probability of each head. For example, if you flip the coin to 1, the probability is almost that's 50%, 0. Around 5 probability. 0. When you flip the coin, that increase the number of trials to 2, the probability of the heads of 2. 1 is this, 2 is almost 0.25 something, and 6, when you flip the probability of 6, that is the probability that is 0.2 something, 0.02 something. So we can see here 0.2 something, because the number of coins, okay, that is when you increase this, when you see that is 0.2 something in when you flip the coin to 10 times, then the probability of counting the number of heads, 6 heads, is 0.25 something. Here we get in the above 0.2, yeah, 20%. The median of this binomial distribution of counting the number of heads are 0.5. That's 50. I mean 0.24 something, not exact 5. So this is so we can increase or decrease the number of experiments, and we can find the probabilities of the number of heads. When the number of heads for each experiment, when 0, it gets 0.05, 1, 0.5, 2, 0.35 above, and 3, then 0.25, and 4, 0.05 or 6 around. So you can increase the number of it. So note that as x increases, that is the number of experiments increases. I mean the number of interests, the number of counting the number of heads increases. Here, the bar gets smaller. That is like this, the number of heads. This is because the sum of the heights of all the bars will always equal 1. That is the probability of failure and success is equals 1. That is the height of the bar. And so when x is larger, the number of heads we can observe increases actually. And the probability needs to be divided between more values, because probability will become decreases when the number of heads that can be observed increases, and the size also increases, because we divide the number of more values to get the probabilities. That the probability become less, because we divide more values to get the probability. So this is how we can calculate the probabilities using binomial distributions in Python, and we plot this binomial distribution bar plots using. Okay, thanks for watching.